All right, hello, my wonderful students. This is part 2 of foldable number 4. For this one here, we're going to do similar thing. We're going to go ahead and factor out this. And remember, the first thing we want to do is look for a GCU. So if we notice here, just like the first part, this one has a common factor of x squared. So we're going to pull out our x squared here. Oh, no, it's fine, x squared. And we're going to see x to the 4th divided by x squared is x squared. Negative 2x cubed divided by x squared is negative 2x. And negative 8x squared divided by x squared is just negative 8. Then we're going to go ahead and do our x factor, and put our negative 8, so multiply to equal negative 8 on the top, and add to equal negative 2 on the bottom. This would be 2 and 4, but in order to get negative 2, we have to have that 4 negative. So this would end up being our x squared. Kind of close this up a little bit. And then our x plus 2 and our x minus 4. This means our zeros are going to be x is equal to 0 and negative 2 and positive 4 because they're the opposites here. We are going to have multiplicity 2 on this one, so this is also going to be multiplicity 2. So we're going to put our zeros, so we have 1 at 0, negative 2, and positive 4. And we know this is x to the 4th power. Because of that, if we look at our end behavior to here, and behavior, for x to the 4th, it's a positive even. So this is going to be of up and up. So we know the graph's going to come from down this direction, and we're also going to leave from the up direction, which is kind of weird because if we went down and then go back up, and then that doesn't work that way. So one of these is going to have to kind of touch the point, but not actually cross the point. And we kind of get a gist of which one it's going to be because we do have a multiplicity of 2. So usually when we have a multiplicity of 2, that's the one that it's going to be. But for this one, we're actually going to test a few points out to see which ones work out. So we're going to go ahead and, well, we know we're doing red. We know this is going to come from this direction here because it's an up and up. We don't quite know the angle because we didn't test the point, but we know it's going to come here. But in between this, we do have a negative 1. So we're going to go ahead and plug in negative 1 here and see what we get. So we have negative 1 to the 4th power minus 2 times negative 1 cubed minus 8 times negative 1 squared. So negative 1 to the 4th power is just positive 1. Negative 1 to the 3rd power is negative 1 times negative 2 would give us a plus 2. And this negative 1 squared is 1. 1 times negative 8 is negative 8. This is going to give us a negative 5. So we know this is going to be all the way down here. At negative 1, negative 5 is going to be a point. So this graph's going to come all the way down here, touch, and come all the way back up at 0. But we don't actually know if it's going to cross or come back down. So what we're going to do is we're going to test this point here at positive 1 and see what that looks like. We'll do this one in black just to differentiate from here. So we have positive 1 squared minus 2 times positive 1 cubed minus 8 times positive 1 again squared. So we have 1 minus 2 minus 8. So this is going to give us a negative 9, which is way down here. So if you notice, we're actually not going to cross this here. We're actually going to go down. And this will go down even further than the graph can actually go. So I'm just going to go that, stating that it's going to keep going. And it's going to come back up right here and then go all the way to infinity as well. I'm going to kind of just connect this just so you guys don't blindly see. But just know that this is going to go like way down here before it rises back up to see this number over here. In order to check how far it actually goes down, you can actually check this one here, and this would tell you how far it goes down if you plug in a positive 2 here. But we ran out of space, so we're just going to go ahead and skip that part. So once again, you can also plug this into the calculator, and this will give you a much better idea of what it actually looks like. But it should technically look similar to this because we are still going from up. We're starting up and we're finishing up as our end figures go. And we're doing our multiplicity 2 where we're kind of just touching the point and coming back down. Or you can call it as it just kisses the point and comes back down.